Hi, I'm Richard, and in today's tutorial we'll be using a 3D algorithm that will create crazy shapes like this one. So let's get started. Hi and thanks for watching, and in today's tutorial, yes, we're going to create a script that's going to do this for us. Yes, it's going to create this rather freaky, crazy looking algorithm, and actually it's not as hard as it looks. There's no question there is some maths that you've got to get your head around, but we'll take some baby steps and we'll do this. This actually follows on from a paper by this guy Paul Bork, written in 2003. What you need to do effectively is set x, y and z values based on a given latitude and longitude of a sphere, which we'll talk about how we create that in a moment. But so for a given latitude you would run this function, and for a given longitude you would run this function, and then you for each of these then you just sort of kind of multiply them together in sort of a different variety of ways to create your x, y and z values. So I know it looks pretty complicated, but actually it's one of these sort of mathematicians' ways of writing what perhaps a program would write entirely differently. And we can look at this. I mean, there's some variables here, a and b. We've got m there. I can see n1, n2 and n3. So a lot of these values actually are static, if you like. We don't need to change them. We can set them at the startup, and it actually, depending on what you select, can produce varying results. And here's a paper of some of the different values. If you plug those numbers in, what you can see. I mean, some of these look really weirdly organic, don't they? I think that's actually a 2 or 3 of that things run multiple times, but you get the idea. You can create some really cool looking crazy shapes. So should we give this a go? Should we have a try? Now, for us to do this, I think the first thing we should do is create a sphere. Okay, so we're just going to go through the basic logic that's going to give us a sphere. Now, you probably see here that I've actually not created a sphere. What I've done is create a whole load of cubes very close together that give the sphere effect, and that's what I'm going to do as well for our basic sphere and going forward. And the reason I did that was because I've struggled in Unity to create mesh and mesh triangles. Now, if anybody happens to know a script somewhere that will create points on an XYZ what do you call that, in 3D space for given latitude and longitude, please let me know and I can take that and just use it. But I tried to create triangles and I just got in a mess with normals and UVs, and oh well, anyway, I won't bore you too much, but this works. This is okay. The only problem is it's a little bit slow. I mean, I'm getting at the moment, what am I getting? Hang on, 20 frames a second. I mean, I'm on a GTX 970 with an i5K processor, so it's not a slow machine, but you know, if this was a sphere, this thing would absolutely rock and run at very high speed. So, but it's going to do. You know, we can tweak the numbers and tweak the values. You can up the number of spheres if you've got a faster computer. Up the number of cubes, excuse me, if you've got a large computer. So, without further ado, let's create a new project, not a new scene, a new project, which we'll call. Now, I've already created one called Super Ellipse Tutorial, so I'll create one called Supershape. Let's go to Supershape tutorial. And let that load. It'll go away. Let's just let that load. I'll pause while that's loading up. Okie dokie, and that is loaded. So let's get cracking and create a script that's just going to very, very simply create a sphere, and we can work from that. And the XYZ values that we use for the sphere will change to use those Paul Bork's values here to create something a little bit more elaborate. So let's have a go at that now. Let's create a C# script here, and we'll call that Supershape 3D. I'm going to call that Supershape 3D. I think I originally called it 3D Supershape, but you can't have a number for the first name of a C# file, as I found out, so that caused a few problems. So I'll just double click that. Let's get MonoDevelop up. Will it work? Yes, it will. I don't know if anybody else has noticed, but sometimes the first time it loads it throws up an error. Okay, let's make that nice and big so you guys can see what I'm doing. Right, so what do we need to do? Let's go through and create a sphere based on latitude and longitude. Now, what I actually brought, you probably may have seen me pull that up a few seconds ago. Latitude and longitude, what are they? Well, the latitude are those horizontal lines that go sort of slice across the Earth. The Earth isn't a sphere, but if it were, then it would look something. Here we go, sort of. And with 90 being the very top point and minus 90 being the very bottom point. And for the longitude, it's slightly different actually. It's from negative 180 to 180. I'm not quite sure why that is. I should imagine there's a good reason for that. I'm probably not thinking my geometry's gone a bit wonky, but somebody I'm sure will tell me. So there you go. So for any point along the Earth, you can give it a latitude and longitude in degrees, and you'll be able to get the position of that place. I'm sure you were aware this is how GPS works with latitude and longitude, and you can be very accurate these days within about 10 feet. So we're going to go through the angles between 0 and 90 for the negative 90 and 90 for the latitude, and negative 180 and 180 for the longitude. And what we'll do is we'll try and calculate what the XYZ point of that should be. And don't panic, because I have the equations here to say what that will be, and then we'll plot lots and lots of points, and that should look something like a sphere. Okay, you with me so far? Bear with me, guys. Let's have a crack at this. So what we're going to do? Well, let's just quickly do this. Let's just say 4 brackets. Int number of segments. Okay, this is important. Well, and we'll just say for now 20. So it's going to have 20 latitude points and 20 longitude points. I'm tempted to make it something like, let's make it 32. Let's make it 64. Let's go crazy. 64. Okay. And what we need to do is we need to say, okay, well, we've got these points along the latitude from minus 90 to 90. We need to kind of break that up into 64 separate latitude and longitudes. Well, let's just give it a go. So we're going to say 4 brackets int. Let's call it LT for latitude. LT equals 0. LT is less than number of segments. LT plus plus. And then we'll do the similar thing. We'll say 4 int ln equals 0. So this is the longitude. Ln is less than number of segments. So we'll have the same segments for the latitude as the longitude, and then ln plus plus. Well, this is great. And we've got our 4 statements, but how do we know whereabouts along the sort of minus negative 180? Am I right? For latitude, it is negative 90 to 90. So where do we know for any given point of 0 to 64? Where should that be? Well, I think the best way we're going to do this is if we create a little function called map. Now, what map will do is it will take the value they're going to pass it, obviously for us it's between 0 and 64, and then map that to something between negative 180 and 180. So that will return a value. So let's have a quick play with that now. What I'll do is I'll just key that in, and if it, so it's float map, and we're going to have the value that we want to get, that we're passing it, and then we'll have kind of our range, current start. Let's have it current start, and then float current end. And then we'll have the float target start, okay, target end. And this is the value, so these are the values we're getting in, so between 0 and 64, and we want to return something between negative 180 and 180. Float target end. Squiggle, squiggle. Alright, and I think the way we're going to say this is, we need, well, for a start, we need to get the range out, so let's just do that. So we're going to say float target range equals target end. Is that right? Target start, target start minus. No, target end is target end. What's wrong with target end? Did I type that wrong? Tangent end, target end, target end. Gosh, need to get rid of insert as well. Target end minus target start. Okay, that gives us, like, if you like, that'll give us 360, because there's 360 points between negative 180 and 180, isn't there? And we'll do the same for the range that we're working with. Okay, so the range we've passed it, which equals current end minus current start. So from that we can work out what the increments are. So what one increment of the current compared to one increment of the target is. So I think if we just say range increments equals target range divided by current range. Okay, so that's saying for each additional value here, what does that take our target up by? I think that's right. And then finally we're going to say return target start plus range increments times, and I need to be careful here because the current start might not be 0, so we should say value minus current start. Okay, if that doesn't make total sense, don't panic, brackets, brackets, semicolon. Okay, so what that's going to do for any given point, let's test this out. So we see 64 here. So what we're going to do here is we're going to say float lat equals map, and it's going to be LT, comma, and we know it's going to be between 0 and number of segments, and we want negative 180 to 180. Alright, and let's just debug that. Debug.log. That's just something like LT equals plus LT plus space, yeah, and then we'll say lat equals plus lat. Just to debug this, and tell you what, let's make that 60, because 60 goes into 360, doesn't it? So let's just see. So how many times? 3. So you make each one to be 3 degrees. 6 degrees. Excuse me, because there's 6 60s and 360. Yes. So let's have a play with that. See how that looks. So we'll quickly. What we'll do is spin back into Unity here. Create 3D object. 3D empty. We'll call this. Did I do that? Yes, I did. F2, and we'll just call this Supershape 3D, and then we'll just drag our script in and run it. And just go over to the console. Where are you, console? Oh, let's turn off maximize on play. That's it. Where's the console? There it is. Here we go. So we spin to the very end. You imagine 0 should be 180. There you go, and it's going up by 6 degrees each time. Fabulous. Okay, and I'm going to assume that works for the negative 90 to 90. In fact, we could try and prove that, couldn't we? Let's spin back to our script here. So it's going to be float lon, isn't it? And that's negative 90 to 90. So it's 180 degrees. So that's only 3 for each one now, isn't it? Let's just let's remove that. In fact, let's just do this. Control X. Actually do that, and then we'll just put this ln equals and lon equals. I mean, make sure you get lon there, otherwise that'll be confusing. LON and ln. Sorry, this is just proving the point. Okay, possibly I should have just taken my word for it. Did that even work? Here we go. Okay, so we can see it starts at negative 90. 1 is negative 90, 3 is negative 90. Okay, so this isn't working. It's possible that I've put the wrong values in the debug. Bear with me. Yes, I have. You can see that I've used LT instead of LN. Yes. Okay, let's try that again. And then we'll run that again. Help me here. Are we running? Are we running? There we go. Okay. So we've got 90, 87, 84. Good, right, that's working. Now, this is good, but for the purposes of the calculations to work out the X, Y, Z, it actually prefers it to be in values of pi. Okay, so we need to convert these back to pi values. So I think the best way we're going to do, so actually, between 0 and 3.14. In fact, I think 360 degrees, and somebody will tell me why, is 2 pi. So I think what we'll do up here is I'm going to create some constants. Okay, const float pi equals mathf.pi, and I know we've got that already, but it'll make it easier, and we'll just see pi straight away, and then we'll just have const float 2 pi equals mathf pi times 2f. I think I'm going to go with. In fact, let's just be consistent from this point forward. And I'm just going to use f's all the time, so there's never any confusion. All right, let's try something like that. All right. Okay, so mathf.pi, and then we'll go const float half pi equals mathf.pi over 2f. All right. You happy? And the way we're going to do this is we're going to say for the latitudes it needs to be somewhere between 0 and pi. At least it does for this one. So 0, pi. And the longitude is somewhere between 0 and 2 pi. Now sometimes, again, I don't fully get the maths on this, because later on we're actually going to be going, so we're going to go to negative half pi to half pi, and negative pi to pi. I'm saying pi too often, it's not becoming a word anymore. I don't know why sometimes it's negative and sometimes it's positive. I do know that if you don't do it this way, you end up with two semicircles, semi-crescents if you like, rather than one large sphere. So now we've got some positions, we've now got latitude and longitude, and we've mapped them to somewhere between 0 and pi for the latitude, and somewhere between 0 and 2 pi for the longitude. And now we can do this rather scary looking but working calculation to get our x pos, y pos and z pos. So we're going to say, so another thing we need to do is set a radius. Okay, so let's do that now. So we say float radius equals 5f. Let's try 5f. And we'll have radius times mathf dot sine of latitude times mathf dot cosine of the longitude. Let's just, I might just copy that and just do y pos and z pos, because there's not a lot of difference, because y pos is the sine of the latitude times the sine of the longitude, and the z is radius is just times the cosine, like that. Okay, and that will give us the x, y and z positions. They're pretty scary, but at the same time, maybe if you're comfortable with how trigonometry used to work around circles, it's not too horrible. We can create x, y and z values. Now, if this was a sphere, we'd be okay, and I could perhaps put, get the points of the sphere and position them round. However, I couldn't get the sphere working. So what we'll do is we will, in our script here, let's just go back to scene, there we go. What we'll do is we'll, in fact, let's go to the script first. What we'll say here is we'll have a game object, and we'll call this point object. Yeah, I don't like that name. We'll go with it for now. Okay, point object, and what the point of that is, oh dear, I'm sorry. What the purpose of that is for every one of these x, y, z's, we'll instantiate this game object. So what we'll do, that should appear here, there it goes. What we'll do is we'll create a cube, like so, and we'll just reset its position, all done. And then what actually, let's just bring it outside. There we go, bring it outside. We'll just, it can be called cube for now. And we're going to make it a lot smaller, because it's definitely not, that's definitely going to be too big if we're going around this sphere right now. Let's try 0.1, 0.1, 0.1, and then we will drag it into here to make a prefab out of it, and we'll delete it. And then Supershape 3D will, Supershape 3D up there. Do you think maybe I should call the empty something different? I'm going to call this Supershape empty, and I'll drag the cube into that point object. Alright, so now what we can do in here, I hope, is say instantiate what do I call it? Point object. What do you think? And the position we're going to put it is new vector 3 x pos, comma y pos, comma z pos. And I think we'll just go with quaternion identity. And what that means is keep the same rotation as the prefab had, which is fine. Okay, so we're going to create lots and lots, 60 times 60 segments. What's that? 3,600 segments, 3,600 cubes. Should we give that a spin, see if that works? Am I still recording? Please tell me I'm recording. Yes, I am. Okay, let's give that a try. Any errors? No, in fact, not even. Let's just clear that. Not even a warning. Okay. So we go over here and run it. Now that is the coolest thing I've ever seen, and it's also completely wrong. Wow! What did I do? I don't know, but I love it. Okay, I'm going to pause this for a second and find out what I did wrong. 1 second. Hi, welcome back. Right, I worked out what I did wrong. I am absolutely thrilled with that result, and it just goes to show you what a little mistake can do. But what I did here, this should be the cosine of the latitude. Apologies if you were screaming at me while I was doing that. Am I recording? Yes, I am. the problem I'm doing, just in case you're wondering why I'm saying am I recording all the time, it's because I do Shift Control S to save everything, and Shift Control F10 is to pause my recording application. So I've been caught out before where I've accidentally pressed pause rather than save, and oh my goodness, I've been chatting away like a good one. Right, so where was I? Sorry, and I've been chatting away like a good one now. So let's give that a try. And there it is. Now we've got arguably either the cubes are too small or the radius is too big. I'm tempted to go with the radius being too big, so let's just break the radius down to, let's try 2f. Let's get even numbers. Even numbers and divisible by 5. Now that looks a bit better. Maybe. Now we can tweak these later on. In fact, we can even just go crazy and just try something like what's 64 plus 32? 96. Let's just do 96. I'll do that there, and then just press that. Let's have a look now, see if that's overdone it. It's 96 is what I was using before, and that works pretty well. What's our frame rate like? It's 35 frames a second. Okay. Well, for now, just to get things in the right place, let's put that down to 64 then, and yeah, and let's just we'll just get this in a rough place that we're happy with. 64. Oh, by the way, what we can do as well, although that's worked out quite nicely here, but what I might do is just this is facing the wrong way, so I'd like to do that. Actually, what I'd like to do is rotate this 90 degrees, but I've noticed this before. We should parent this to perhaps the Supershape empty. Let's try that. So we say here, we're going to need to create a game object, aren't we? Game object cube equals that, and we're going to say as game object here. Game object, thank you, and then we say cube.parent, set parent. Bear with me. So it's cube.transform.parent equals game equals transform.parent. I'm never quite sure. So it's there we go. Transform.parent. Okay, so that the transform being this transform, as in the object is attached to Supershape empty. So now if we run this, you can. Oh, I thought you could see that, but it's definitely not done that, has it? Hang on. Cube.transform.parent equals transform.parent. Boo! I was expecting that to work. Oh no, hang on. Now what you do is you say this. You say cube.transform.setParent. That's it. And then transform.parent. Try a transform. Sorry, transform. That's right. It's I think that's it. Let's try that. Let's try that, people. Give that a go. Be kind. Be kind. People are watching this. There we go. Okay, you can see that now we've got all of them are created under there. Now I think if we're lucky, there we go. Now if we shift that, you see 90 degrees. Now that's working. And what we'll have to do now is just do that to 90 before we run it. Do that. And it hasn't worked, and I'm pretty sure the reason for that will be because needs to be the local position, and what a nuisance that will be. Okay, I'm going to work on that a bit later on. We'll fix that later on because it's not critical anyway at all. So we might as well set that back to 0. Because what we now need to do is work on this rather scary looking function. Not that one. That one. This function here. Okay. Now again, just to let you know, I've basically plagiarised this off of Daniel Schiffman. I don't like to think it's plagiarised. I like to think I've taken his work and put it into Unity, because he does such a fantastic job of explaining stuff into the likes that you and I can understand. I mentioned this before. I'll be sure to put a link into his site. So let's take a look at what this does. So what we're saying is the R value for a given angle, theta, is 1 over A times cosine this M value times angle divided by 4 to the power of n2 plus 1 over B times sine M times angle divided by 4 to the power of n3, all of that to the power of -1 divided by n1. Yikes. Okay, but if we're just careful with this, let's just take this and do it bit by bit. Over here, let's create a method called So what I'm going to do as well, I'm going to move this start here. I'm going to grab all that. Can I do this? Let's just try it. Refactor extract method. I think it has a bit of a complaint, and then we'll just put it down. So what are you doing there? We'll call this create Supershape. Create Supershape 3D. How about that? All right, and then we haven't got anything. There we go. Got a call to it in the start option there. Right, good. And I don't like having the squiggly brackets there. Okay, people. I hope this is okay. I hope you're bearing with me. Take a break. Go and have a cup of tea, and then keep and pause it and carry on. We're almost there. I'll be sure to put the code into GitHub so that you can have a good old play with it. In fact, what I might do is I might make it a Unity package so that you can play with it there. Okay, right. So where were we? So let's create Supershape 3D. What I'm going to do as well is get something that returns the result of this function. So you're going to pass an angle in, and it's going to do all of this nastiness. In fact, I want to get it to pass A, B, N1, N2, N3, yeah, and M in. Right? I'm going to put A and B in. A and B. Okay. I've been setting to 1 and not changing, and I've not seen a reason why to change it. But let's get them to pass them in as well then. So we'll have float, and we'll call this. What shall we call this? Does it give you a name that we might want to call it here? Yeah, let's just try for let's just call it Supershape, and we're going to have a float angle. Well, I think that you can call that theta sometimes, but we'll call that angle. We'll call it theta because that's what they like to call it. And then we've got float A, float B, and then float N1. Let's do float M, shall we? And then float N1, comma float N2, comma float N3. Lots of values. Eek. Okay, but what we can now do is we can say, let's just break it down by piece, shall we? So we'll just do this 1 over A mathf cosine bit, okay? And then we'll power it to N2 afterwards. So let's do that first of all. So we'll say float, part 1, P1, let's call it T1, that's what I called it before. We need the absolute value, so no signs, okay, sign free, of 1 divided by A, yeah, times mathf.cosine of m times theta divided by 4. M times theta divided by 4. Semicolon. Yikes. Okay, that you know, that even worked. And it all needs to be to the power of N2. So I'm pointing at my TV. I do that quite often. Pointing at my TV, pointing at my screen to the power of N2. So we say T1 equals mathf.pow T1 to the power of N2. And I think we use something very, very similar for part. So it's just the second part. Float T2 equals. So everything's the same except it's the sign. It's the sign B and N3. Do you reckon I can take a chance? Let's just copy it from above. Mathf.absolute open brackets 1 over B times mathf.sine m times theta divided by 4, and then we say T2 equals mathf.pow T2 comma N3. Okay, people. Okay, and then we add them together, don't we? Yes, it's those two added together. There you go. Don't forget that. So we're going to have float T3 equals T1 plus T2. And then finally, all of this needs to be wrapped up and powered up to the power of minus 1 divided by N1. Gosh! So let's just say float T4 equals mathf.pow, and that's T3. So the last value we got to the power of minus 1 divided by N1. Return T4. Oh my goodness. Take a breath. I think I have that right. We will find out. And we can plug these values in, I think. To A will be, let's just create them up here. So we'll do float A equals 1F, float B equals 1f float, M equals 1f float, N1 equals 1f. Let's just copy those, shall we? Is that all of them? N2 and N3. And if I'm lucky, all I need to do, I probably should call them something different in here, shouldn't I, to what they are up here. I think it's okay though. I think we're okay. We'll be alright because these are local variables. It just might cause us some confusion to remember whether we're using these ones or the ones that we call in the method. But let's give it a go. So we'll say A, comma B, comma M, comma N1, N2, N3. No. No, that's not in the right place. That one stays where it is. Control X, because that's this method here. It's the Supershape that calls it, isn't it? So we need to get R1. So we go back to here. You can see it's R1 of that value of the angle, right? Then that is the longitude. So R1 of the longitude, and then cosine of the longitude, and R2 of the latitude. So we need to have what R1's going to be this equation for the longitude, and R2 is going to be this equation for the latitude, and then we can run these numbers in. So we'll just say, hang on, make sure I get around the right way. So we're saying sorry guys, so that squiggle is the latitude, which is the R2, okay? And apologies, I don't make a lot of sense. It doesn't have to be that, but I think for clarity it should be clear. Float R2 equals Supershape LT, and then A, B, M, N1, N2, N3. And then for here, that's the latitude, and then here we're going to do the same thing. Oh no, that should be lat. That should be lat as well, and also that should be below that line there because we haven't calculated lat yet. There we go. Okay, and then for this bit here, we're going to do a similar thing. That's going to be R1 of the longitude. We're passing exactly the same values in, you see. So although there's a lot of the values, they don't change per se very often. All right. There's no radius anymore. Do we still use the radius? Doesn't look like it. So maybe A and B are the radius. Eek. Not sure. But let's just comment those lines out. We don't want to lose them. And then we'll try again. So now we're going to say float xpos equals, so it's R1 times mathf.cosine of the longitude. This is longitude, isn't it? That's the squig. That's the zero looking one, times R2 of the R2, just R2 times R2 times mathf.cosine of the, which is the squiggle, which is the latitude. Oh gosh, guys, I hope that's close to being right. Let's just copy that 3 times. Xpos, Ypos, Zpos, Zpos. Okay. So the next one is R1 times sine of the longitude times R2, which is, we've run this function already, remember, so R2 of that squiggle is this thing that we've run here already, times the cosine of the latitude. Oh, it's done the same, so they're the same, yes, they're the same. And finally, R2 times sine. So that's times mathf.sine of this squiggle here, which is the latitude. Eek, right. Oh, yeah, right. Does that even compile? No. What's this one here? That should be POW, shouldn't it? POW. Capital P. Must have mashed that up at some point. Go back in. Okay, Supershape radius is defined but never used. That's very true. It's not used anymore. Okay, but we've got ourselves a whole bunch of variables that we're passing in. I wonder. Should we just run it? See what happens to start with. Let's get the scene going. Okay, now I know the first problem we've got is that it's gone inside itself. Can you see that there? It's gone inside. And like I said, that's because this one, it's slightly annoying because now I can't use, I've got two different for loops, but this one goes from negative half pi to half pi and negative pi to pi. So let's just do that. So that's negative half pi to half pi and negative pi to pi minus pi to pi. Slightly annoying. Okay, if you did that with these ones, that would return a very similar result. Okay, let's give it a quick go. And we've got something that looks a bit weird and definitely looks like it's got itself a shape. If we just select something else, okay, colour-wise it's terrible, but there you go. But it's there, isn't it? Now I happen to know that if we just go and change these values up here, I need to get my values right. In fact, I think even if we spin over to the page over here, there might even be an option for it to show you one of the ones I'm talking about. Is it this one? If we go for 0.2, 1.7, so we go for N1 is 0.2, N2 is 1.7, and N3 is 1.7. So let's do that. So set them to 0.2, 1.7, and 1.7. And then what was the other bit? So, and then we go for M1 as 0.2. No, that cannot be right. M is 7, excuse me. M is 7. Okay, and excuse me, let's give it a go. I think it'll actually work. Where was I running that from? I very much expected that to be different, but it isn't different. A, B, M1, M1, N2, N3. Where's my script? Here it is. Let's run it again one more time. Looks exactly the same as it did before. Makes me think I haven't saved it. I have not saved it. Am I paused? I am not paused. Sorry guys, mild panic there. I was trying to work out where I was. Okay, so let's run that again now. Bang! There you go. So you've got this really weird looking shape now. I'm going to do something. I'm going to put a different. I'm going to put a different material on this cube. I'm going to do that now. Create material. Anything. I don't really care as long as it's a bit darker. Let's go for a blue. Show a darker blue. So okay, that'll do. And then we'll just drag that material onto the cube. Does that work? Go to the cube. Yes. Now if we run it, at least I think it'll be something a little bit there. That's a bit better, isn't it? Bit more view. As you can see, I mean, it's kind of weird that it's you know, these cubes, but it's not terrible. It's definitely viewable. Let me work on the getting this rotation sorted. I'm very sure it's something to do with the fact that we needed to make this a normal. So what we're going to have to do is we're going to say if we're going to make that it kind of bulge in and out like it does, then what we're probably going to have to do is have these vectors stored. So let's create a 2D array here of vector 3s. That's what we'll need to have, won't we? Won't we? Yeah, we'll need to have yes, vector 3, LT and LN. So let's do that. 1 second. So up here we're going to say vector 3. So it's multi-dimensional. We're going to say points or something like that. And then I'll create Supershape here. We're going to have points equals new vector 3. That's it. Num segments, comma num segments. Num segments, comma num segments. Semicolon. Down here we say points LT LN. Okay, so the multi-dimensional array equals new vector 3. Let's just copy that, shall we? Look at that, I didn't have an opening bracket. There we go, semicolon. And now here we'll just change that to that. So that should still work. And now what we can do, you see, is we can run this multiple times. In fact, what we'll probably do is something along the lines of saying this thing: if brackets points LT comma LN, get it in, LT comma LN is null. Yeah, that's it, like that. Else we say no, we set it to the game object, don't we? Excuse me, it's not a vector 3, it's a game object. Where's that gone? Here, so that's game object. And then down here what we do is we say cube, that's it, so not that point, so we'll just do that. Game object cube at the position we want it to go, and then we'll say points LTLN equals cube. I'm calling it cube, of course, but it didn't have to be a cube that I used, did it? Points LT equals, otherwise we say cube dot excuse me. Yeah, sorry. So we say points LT comma LN dot transform dot position equals. Now we need to move. Where's the vector 3 gone? Yeah, so you say here we'll say vector 3 pos equals new vector 3 brackets x pos comma y pos comma z pos, and put that to pos like so, pos. So whenever if it's never done before, create this array. Otherwise, you see what this allows us to do updates every frame. You see, and it won't create new objects every time. Equals pos. You can do that. So resetting the transform position will move this around. I think that's going to work. Yep. What's wrong with this? As game object, what did I set it to? It gives you game object. How's that? We good? No, yeah. Radius never used. Yeah. We're still in good shape. Still there. And now what we can do. So now we've done this. We can loop this round over and over again, but what we'll do, rather than setting M, A, B, and M like so, is let's just have a float M here. We don't want that to be there now anymore, because otherwise that'll just reset them every time. So let's just put that into the start method. So we'll get rid of M up here. We'll just comment that out for now, so we know it's not the right one. And then so this takes M in, and what we'll do is, I think what we'll say is call it in here, and we won't call it in here anymore. We'll call it here, and let's just do this. Let's just run that as 7F for now. Okay, so we're going to run it every single frame. And I know that's stupid. It won't actually change the positions. It might slightly be interesting to see, but okay. How's that? Let's give it a quick try. Okay, it's not moving, but it is calling it every single frame. In fact, I'm surprised it's as fast as it is. I'm guessing maybe because it doesn't. It's interesting because update is being called and it's creating Supershape 3D every time. Okay, all right. Well, let's just try this. Let's just try time. Time. Okay, that's going to start at 0 and work through to 7. I don't know what's going to happen once it goes past sort of 10, but let's just give it a go. There it is, look. There it is. Going pretty crazy. And it'd be handy to know what M was, but now it starts to go mad. I mean, I don't know, what's it been running, about 10 seconds now? Oh my goodness, I love it. It's doing this. Ooh. I don't know what's going on. Okay, so what we can do here, rather than we'll say time.time %. Let's try up to 10. Is that even going to work? So what that's saying is once it's gone to 10, it'll go back to 0 again. Oh, that's going to look a bit weird when it gets. It's probably going to just stand back to 0. Let's have a look. This is the kind of effect we're looking for here. In fact, I might just make that bigger so we can see what's going on. Yeah, so it's gone back down. Okay, all right, not great, but it's also doing some rather weird things. But I like the way it looks. Okay, and what are we doing at the minute? We've only got about, how many points have we got? 64. So let's just up that to 96. I might make the cube. Here we go. Oh, 0.1. Let's try it. Yeah, that slowed it right down, hasn't it? Now it's 20 frames a second, but doesn't it look cool? It's just too weird. There we go, it's going to 0. So what we need to do is use something like a sine wave. Okay, so a sine wave goes between 0, -1 and 1 in a circular fashion. Let's just show you, hang on. Let's find it. Mathf, sine wave. And we'll use that map function. Here we go. So it goes up and down. So whatever values you pass into it will just go up and down. So you go 1, 2, 3, 4. Doesn't matter. It'll always follow this sine wave here. So what we can do is something along the lines of using one of those maps. So we'll say float m equals map time.time somewhere between -1. No, we're going to get a value of hang on, sorry. So excuse me. So it's the value is going to be between -1 and 1, isn't it? -1 and 1. And the range is, hang on, I've lost my marbles. Time out. Sorry, this is going to be mathf.sine of time. Okay, so that's going to, so as time goes on, time is going to return a value between -1 and 1, and we want the values between 0 and 7, or 0 and 10. Should we try 10? Okay, so that's going to return, so this thing here, the value there, sine of time.time, will just keep going up and down between -1 and 1, and we want that between 0 and 10. So then we should just put m in there. We start to see results, I hope. There it is. It ain't too quick. It's pretty chunky, isn't it? So let's just bring that down to 64 again, just to get some sort of purchase on it. Shift Control S. Still recording? Yes, I am. Come on. Yeah. Which way do we want this up? I think we want it that way up, don't we? I don't know where we want to look at this. I'm just moving it around. Sorry if that's confusing. What I'd like to do, I think, is get this facing the right way. So the way I'm going to have to do that is, and this is a little bit of unnecessary tinkering around, I probably encourage you to do this, is along the lines of, now we've set the transform, we can change its, now we've set the parent rather, we can set it along the lines of, yeah, we can say cube.transform.local position equals pos. Okay, right. So by setting local position, what we're saying is local to the parent rather than world coordinates. And I think here we just say transform.local pos. Local position. There. Okay. So if we don't do that, then it sets it to world positions. This is kind of weird now. I don't know if there's a way of doing that in instantiate. I don't know. Right. So let's try it. I don't know where my angle is anymore. There we go. So now hopefully, if we get our super shape and change that to 90, that's better. There we go. And now we've got something. Gosh, look at that waist. That's better. That's better, albeit a little dark. Maybe if we spin it around there. That's better. And what we can do down here now is if we just go to the main camera and we'll click Game Object Align with View, and that zooms it in. But what we'll need to do if we're going to keep that camera position is we're going to need to say Copy Component. We'll stop it, make sure main camera is still selected, and say Paste Component Values. And now if we, let's just maximize on play. Click here. I bet you I didn't. I must have been running the. Yeah, this is annoying. You see, there we go. So I'm going to have to set that back to 90 again on that one. It's because I was playing it while I changed the rotation on the X. So now let's do that again. And there you go. Now we can tweak these values, and I advise you to go to the Paul Bork webpage over here and just look at some of the ones you can do. These are kind of from and to. All right. So this, yeah. So from 7 to this is interesting. This one here. Look, you can see this is going from A and B is always 1. What's the difference between the two? I can't see it yet. M equals 7, A equals 1, B equals 1. So there's no difference between the two. So I'm not sure why. Am I blind? Am I missing it? If I am missing it, I certainly don't see it. But let's try this one, for instance. So let's try M is 6, 1, 1, 1. M between 3 and 6, 1, 1, 1. Okay, let's try it, shall we? Let's give it a go. Up here, so these are going to be 1, 1, 1, 1, 1, 1. What was A and B? It doesn't say anything about A and B here, so we'll just leave them alone. It does say about A and B there. Okay, and between 3 and 6, right? So let's just 3 and 6. Let's give it a go. I don't even know if this is going to work. Yeah, there we go. That's created another cool effect. So you can actually go to the Paul Bork website and try a few of these out. See what happens for you. I added a floor earlier on just to show the shadow. Should we do that? Should I just show you how I'm doing that? Just create 3D object quad, and I think I have to make it quite large. It's just it's facing the right way at least, I think. Yeah, hang on. Maximize on play. Pause, and then pull that. Ah, it's in there. Look. So let's just reset there. And then just put it down there, and then we'll just set it to something like 20, 20, 20, like that. And then make sure you copy the component, switch it all off, and you've gone in there. That's annoying. And then we hopefully just paste component values, and it will still work. And now I need to maximize on play. There, you can get an idea of what's going on from a shadow perspective. So how cool is that? I hope that made sense, guys. I would love to hear your feedback on this, whether you think this is any good. There's all sorts of things I can imagine you want to do now. You might want to change the colours depending on the cube position or something like that. You'll definitely, if you're interested, want to try and make a sphere out of this, because then it will run really quickly. Please do have a play with these values and see what sort of results you can get. I mean, some of them get pretty weird as you go down. One thing I've noticed is that they go from, some of these n values go from different things, and obviously at the minute I'm only tweaking m, so you might want to think about how you can do that. Here's an interesting one that would look like a UFO, some just general shapes, all really good fun. Look at that, looks like a pair of legs or something. I don't even want to say what that looks like. A fan, and oh, look at that. Well, how much fun can you have playing with these algorithms? I personally, I like this one, but I liked the other one a whole lot more. Looked like it. I don't know. It almost looked like it was alive and trying to I don't know, like it lives in the sea or something. Anyway, I'll shut up now. Thank you very, very much for watching. Please comment, please let me know what you think. You know I love subscriptions, you know I love likes. I look forward to hearing all of your thoughts, and heck, seeing what you've done with it as well. I look forward to seeing you next time. Thanks, guys. Bye bye.